Most of us are exposed to the famous situation in which our elbow hits the wall or something around us, and we suddenly feel a sting of electricity. Many times, when we come to greet someone, we may feel that we both have been electrocuted. The same thing also happens when we come to touch a metal object, such as the door of an apartment door, a door, or a car door. In all these cases, we feel that there is electricity suddenly entering our body, and sometimes there's even the sound of an electrical short. So, what is the reason behind this strange phenomenon? It's an excess of electricity present in our body, as some people believe. And is it harmful to our body or not?
But first, welcome to this video from one of the Curious Knights.
Any substance is made up of a group of atoms, and the atoms are made up of three elements: electrons, which carry negative charge, protons, which have a positive charge, and neutral neutrons. Because the number of electrons is usually equal to the number of protons, the atom in general is either chargeless or electrically neutral. And that's why most of the materials we deal with daily are neutral and do not contain any electricity. But why do materials emit a charge that electrifies us when we touch them? This electricity occurs because of electrons. Electrons are tiny, almost massless objects, and that is why some violent mechanical processes, such as friction or rubbing, affect the electrons and break the bonds that hold them. So they move them from their place and move to the atoms of the material that's in contact with them. This is the condition in which a feeling of electricity occurs. This is the phenomenon that we call static electricity or strategic electricity. This is the interpretation of a game when we get a pen and scratch it in our hair a lot. Then we bring it close to any piece of paper, and we find that the paper is stuck to the pen. The friction of the pen in our hair changes its charge and makes it lose some electrons. This means that the number of positive protons is more than the negative electrons, and therefore the pen turns into a positively charged body. So when we bring it close to any neutral body, such as paper, in our example, a group of electrons begins to withdraw from the atoms of the paper and move to the pen, and this is what makes the paper and pen close together. But after a balance occurs between the number of charges, each body begins to separate from the other again. Electricity is nothing but a flow of electrons that move from one place to another. That is why if someone wakes up from the sleep and then immediately goes to hold the hole in the door, and then immediately goes to hold the hole in the door, they will be electrified, but on the condition that it does not touch any other object before touching the hole. The same applies if someone is wearing a wool sock and walks on the carpet, and then opens the door to the apartment. It will also most likely be electrocuted. So what makes this happen? When any of us sleeps at night, they certainly keep tossing and turning in the bed all night and rubbing the pillow and mattress. And because of this, a positive charge is formed on the person's body as a result of the friction of the bed all night. The same applies when the foot rubs against the carpet more than once. This friction makes the body gain a positive charge. When you go after them, you hold the metal cells, which are usually electrically neutral. The electrons will move from the cells to your body to neutralize them. That's why the person in this condition feels the sting of electricity. Does this happen with anybody with a neutral charge? Of course not. The issue specifically occurs with metals and some other conductive materials, such as salt and others. The scientific explanation for this phenomenon is that the elements that conduct electricity have weak bonds to their external electrons. Another question: why do we get electrocuted when we hit our elbows? In principle, other factors contribute to feeling the sting of electricity. One of these factors is due to the static electricity that we talked about, such that a person has a positive charge in his body and then flops with his elbow on any metal object. The other factor is related to the nerves. This is a group of sensitive fibers that extend along the arm and pass from behind the elbow joint to the little and ring fingers. The fibers are known as the ulnar nerve. Evidence from this topic is that the elbow area specifically does not have an internal membrane that protects this nerve from shocks, especially if you flop with your elbow while your arm is at a right angle. That's when we hit our elbow. The shock from the hit puts pressure directly on this nerve. This is what causes the painful feeling of electricity that happens to us. This feeling is usually stronger than the feeling of strategic electricity, especially since the nerve is not only responsible for the elbow, but it extends to the extremities, as we said, and this in turn makes the electricity heard throughout the arm. Okay, what are the reasons for strategic electricity? One of these reasons is the weather. Most electrical shock occurs in the winter and fall, and this is because the air in these seasons is dry and carries a small amount of water vapor. In the end, although static electricity does not pose any health risk and is a very natural phenomenon, there are no problems with it. But also, these are some tips that can help us avoid electrical stings. In principle, we try as much as possible to avoid wearing any clothes made of synthetic fibers or fabrics, and we try to replace them with cotton clothes or clothes made of natural fibers. Another thing we can do is avoid wearing shoes made of rubber because it increases the accumulation of positive charges on the body, and replace them with leather shoes.